And good morning. We're going to go ahead and start section 7.1 in Principles of Math Part 2. So go ahead and look in your book. We're going to be on whatever page this is, page 133. All right, so this section is called Simplifying Multiplication. So a large portion of math is about learning conventions, notations, and techniques. All of that help us to simplify expressions. But what do we mean by simplifying expressions? Well, remember that an expression is a collection of symbols that jointly express a quantity. For example, 4 times 5 is an expression. 4, 5, and dot are a collection of symbols that together express the quantity 20. Thus, when we refer to simplifying an expression, we mean to express it so it's as easy to understand and work with as possible. Now, you've already been simplifying expressions for years. 4 times 5 simplifies to 20. Both 4 times 5 and 20 represent the same quantity. Only 20 is a simpler way of expressing that quantity. 4 over 6 simplifies to 2/3. 4 over 6 and 2/3 represent the same quantity. Only 2/3 is a simpler way of expressing the quantity. And there's a picture of that right there showing you why it's more simple. It's more simple to say that there's 2/3 of a pizza left rather, or 1/3 of a pizza left rather than saying, 2/6 are gone or whatever. So in this chapter, we're going to look at some ways to simplify expressions involving unknowns. That way, you'll be even better equipped to handle the real-life problems that you'll encounter. So we're going to start by taking a look at a convention that we can often use to simplify how we express multiplication. All right, let's look at this page here. When we're multiplying all numerals, we have to use a multiplication sign. When working with letters or non-numerical symbols, we don't need to write the multiplication sign. The convention is that the absence of a sign between letters or between a figure and a letter indicates multiplication. So here's some examples. So 3 times x means 3 sets of x, or x plus x plus x. And that can be written as 3x. Okay, so this, same thing as this. 5 times pi means pi 5 times, and it can be written as 5 pi with no symbols. Y times x can be written yx. So like I said, the convention is when there is no sign between letters and they're beside each other, or a number and a letter, it just simply means multiplication. Okay, this convention should not be totally unfamiliar to you. You've already been omitting multiplication signs in front of parentheses like this. We've already been doing this. This means 2 times 5. And so if you're using two numbers, obviously you're going to need parentheses or the dot, because you can't, because if you put 2 and 5 beside each other, it's 25. We've also shown geometry formulas using this convention at times. For example, the figure below shows the 3 ways used in Book 1 to represent the perimeter of an equilateral. All sides equal. Triangle, using S to represent the length of each side. Notice that in the last way we omitted the multiplication sign, see? So the perimeter of a triangle is S, or side plus side plus side, or 3 times S, or just 3S. Now always make sure you understand the principle. The principle is to omit multiplication signs when you can without leading to ambiguity. Ambiguity. It's kind of a big word. If we have units of measure, we'll often need a multiplication sign, even with an unknown, in order to avoid confusion. For example, we wouldn't write 10 feet times x as 10 feet x, because that would be confusing. Instead, we'd continue to use the dot or the parentheses. And there it shows you right there how you would do that. So sometimes you have to. You just have to use your mind as to, what would be the best. Obviously, if we replace an unknown with its value, then you'll also have to include the multiplication sign. That's what I was talking about a while ago with the 2 and the 5. If you have 3 times 5, you wouldn't write it this because that's 35. So when you have two numbers or you have, units and things, sometimes you do still have to use it. Now we're going to take a look at an example of working with a formula where unnecessary multiplication signs have been omitted. So let's look at this page. We saw in the last chapter that we can rearrange formulas to solve for different unknowns. For example, we can rearrange the percent formula to solve for the base. Remember, rate times base equals perimeter. Listen to me. Rate times base equals percentage to solve for b base. In order to do that, you want b by itself. So you divide both sides by r, as they did here. You're left with base equals p over r. Okay, that's just rearranging your formula so that it's easier to get your answer. Okay, now the following example shows the same thing written without the multiplication sign, even though we've not written the sign. RB means R times B. Thus, we can still rearrange the formula the same way we did before. So RB equals P. Okay, rearrange this to solve for B. Well, this means times. RB beside each other, it just means times. There's no symbol there. We just know it's the convention that tells us it means times. Okay, we want to get B by itself, so we're going to divide both sides by R. That cancels the R's out. We're left with B equals P divided by R. Now, what is a convention? Now, it's important to differentiate between the adopted conventions in math and the underlying consistencies. Now, God created the underlying consistencies, and they remain the same throughout time. Multiplication consistently works the same way. The way we describe consistencies, though, can and does vary. For example, you now know quite a few ways to describe multiplication. God's creation is so amazingly complex and intricate, though, that we frequently need to modify conventions in different branches of math in order to describe it. When you get to calculus, you'll learn that in calculus, the letter D is considered a special symbol rather than an unknown. So in calculus, dx does not mean d times x, but rather something completely different. Again, remember to view conventions as helpful tools to describe God's creation, tools that can be modified if needed to serve the end. Exploring and solving real-life problems. Above all, remember that we need so many different tools in math because God created an incredible universe. He is so much greater than we can ever conceive. All right, so let's look right here. There's also a convention about whether to write 3 times x or x times 3 or 3x or x3. Since multiplication is commutative, that means the order doesn't matter. Both 3 times x and x times 3 yield the same product. So rather than writing them both ways, the convention is to always put the number first. So we would write both 3 times x and x times 3 as 3x rather than x3. And both 2 times pi and pi times 2 as 2 pi. Okay, so the convention is number goes first, variable goes after it, and it means times. That when I say a convention, that just simply means that's pretty much what everybody knows to be true. Okay? This convention applies when we insert values into formulas too. For example, you know the rate times the base equals the percentage. Let's say you know the base is 100, the percentage is $5. Rather than writing R100 equals 5, put the numerical value before the unknown, like this. 100R equals $5. We also follow a consistent convention in reading multiplications by unknowns. Rather than saying 3 times x, we read 3x as 3x. Okay? So these are just conventions, normalities in math that most everybody knows, kind of the way that it's just always been done. Okay? All right, let's look at our worksheet. It's worksheet 7.1. Now this says to rewrite the following multiplications by putting the numeral directly before the unknown. It gives you an example. So 5 times x would be written 5x. So you're going to rewrite all of those in that way. Okay? Now on 2, it's repeated additions, which is what multiplication is. You're going to rewrite these repeated additions as multiplication. When there's an unknown, show the multiplication by putting the numeral before the unknown. So if you had x plus x equals 2x, that would be that. So this one is 6 plus 6 plus 6. An example might be 3 packages at $6 each. Okay, so your answer here, let me see how they how they put it in the book so I can make sure I show you the right way. It is, oh, I'm on the wrong page. Yeah. So on this one you would have, because you don't have any variables in this one, so it would be $6 times 3. And you just write it however. Okay? All right. Now on part 3, evaluate. I.e. means example. Find the value of. Okay? So find the value of these expressions. So you're just going to, it tells you what x equals. And so you just write down what the answer would be. Easy peasy. All right, on the next page, you've got C, D, and E, a little bit more from the first page, and then you've got a skill sharpening section. I'm not going to grade anything in this, and just let me know if you need any help. This is a very, 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 very important lesson, so I want to make sure that you get this down really good, okay? So, again, let me know if you need any help on it, and that'll be all for today. Yeah!